So now we're going to look at the same election results we had in a previous example, but we're going to do something called the Borda Count method. With the Borda Count method, we're going to assign points to a candidate based upon where they are in somebody's preferences. So whoever gets first place votes gets more points than whoever has last place votes. Now, here's how it works. We look at how many preferences we had. In this particular election, there were 4 different preferences that people could list. They could list things 1 through 4. All right, so whoever is first place gets 4 points in this case. Second place gets 3 points. Third place gets 2 points. And last place gets 1 point. So if there were 6 different orders that we could put things in, there would be 6 points for first, 5 points for second, 4 points for third, and so on. If there were 10 different rankings that we could have, it would be 10 points for first, 9 points for second, and so on, all the way down to 1. Okay, so to do the Borda count, it's a little more complicated. All right, so let's notice A. A is in first place in that first column. So those 10 votes will receive 4 points each. So we do 10 times 4. All right, now in the second column, A is last. So those 10 votes will only get 1 point because it's last. In the third column, there's 9 people in that column, and A is last. So A will only get 1 point for each of those 9. In the fourth column, A is in third place. So for these 4 people in that column, third place is worth 2 points. In this column, A is first, so it's going to get 4 points for the 2 people there to there. So it'll be 2 times 4. And for these 2 people, A is third, so it's going to get 2 points. So it's going to be 2 times 2. And then we've just got to multiply all of this out and add this up to get its actual Borda count. Now let's notice that this is, oops, I messed up there, 8 plus 8 plus 4. So this is far more tedious than some of our other methods. But let's go ahead and, so this particular Borda count adds up to 79. All right, so let's do B. Oops. All right, so B, if we look at the first column, B is in second place. It gets 3 points for each of these 10, so it's 10 times 3. The 10 people in the second column, B is first, so B will get 4 points there. The 9 people in the third column, B is third, so it'll get 2 points for those 9. The 4 people in the fourth column, B is second, so it will get 3 points for them. The 2 people in the next column, B is third, so it will get 2 points. And the 2 people in the last column, B is first, so it will get 4 points. So again, we want to multiply these out and then add them up. So we'll have 30 plus 40 plus 18 plus 12 plus 4 plus 8. And let's let our calculator do that. And this will give us 112 points. All right, now let's do C. So for C, let's notice that in the first column of 10 people, C is third, so it gets 2 points for those 10. In the next column with 10 people, C is third, so it gets 2 points. In the third column, C is first, so it gets 4 points. In the fourth column with 4 people, C is last, so it just gets 1 point. In the next column with 2 people, C is second, so it gets 3 points. And in the last column with 2 people, C is last, so it just gets 1 point. So we have 20 plus 20 plus 36 plus 4 plus 6 plus 2. So let's see, that's going to give us 40, 76, 86, 88, if I've added correctly. And then let's go to D. All right, so for the first 10, D is in last place, so it'll get 1 point. For the next 10, D is in second place, so it'll get 3. For the next one, D is in second place, so it'll get 3. For the column with 4 people, D is in first place, so it will get 4. For this column, D is in last place, so it will get 1. And for the last column of 2 people, it's in second place, so it will get 3. So that's 10 plus 30 plus 27 plus 16 plus 2 plus 6. And again, let's let our calculator do that. That is 91. Now, it would be nice, as we can see, this has got a lot of room for making mistakes, and we could make just a simple mistake of adding things up or multiplying something, have our border counts off. Here, B wins this border count, but if I made a mistake and that's not the actual total for B, it could be that D wins. So what we want to do at the end is check and make sure that we have not made a silly mistake somewhere in these computations. So how do we check that we've not made a mistake? Well, if we add up all the voters, there are 37 voters. So if we take 37 voters, and if we add up the points that we are distributing for each of the columns, 4 plus 3 plus 2 plus 1, there's 10 points right there. So if we take the number of voters times the number of points that we are distributing across those voters, there should be 370 total Borda points that they can earn all together. So if we add up 79 plus 112 plus 88 plus 91, we should get 370, and in fact we do, meaning no mistakes have been made in doing our border count. If we do find that we add those up and they aren't equal to what they should be, then we've got to kind of go back and figure out where our mistake is. But I want you to note that if you kind of line things up the way I did, where you have your voters first and how many points they get second, you can look at this and go, okay, I should have one of each quantity of points right here. And then voters, and notice 1, 2, 3, 4, and then voters, and 1, 2, 3, 4, and voters, and 1, 2, 3, 4, and so on. So you can go back and see where you might have made your mistake if you write your work out. Now, at the end of each of these, we've been talking about what's wrong with a particular method. This particular example does not have the criterion, does not have the problem within it, but the problem with the Borda count is sometimes it violates what we call the majority criterion. So if someone has a majority of first place votes, they should be the winner of the election. All right, so if we do a plurality election and somebody has more than 50% of the votes, they should win the election. That's what this criterion is saying. Borda count can sometimes lead to that particular criterion being violated. We can actually do a Borda count and the person who doesn't have over 50% of the votes doesn't win, which is the problem with that particular voting method.